All right, we're going to go through some practice together now. So let's read number 2. A photon is released with an energy of 7.67 times 10 to the minus 19th joules. What is the frequency and wavelength? So the first thing, again, that we need to do when we read a question that has information like this, we need to identify what information we actually have. If it's going to be a math problem, we need to identify what our variables are. Okay, so the first thing that I see is I see a number, and I'm going to figure out what variable that is. It says that it's my energy, so my energy, E, is going to be equal to 7.67 times 10 to the minus 19th joules. Then I need to identify as well what I am going for, what I'm trying to solve for. So it asks me for my frequency and my wavelength. So let's go back and think about the equations that we have, the equations that I'm going to use. Of course, right, I'm going to use E equals h nu and C equals lambda nu, but I have energy and I'm trying to solve for frequency and wavelength. So this first equation, I'm going to start at the energy, but I need to solve for my frequency. To solve for my frequency, I need to divide both sides by h. When I divide both sides by h, that cancels, and I'm going to be able to use nu equals E divided by h. Once I have my frequency, then I can go and I can use it in this equation. But again, I need to rearrange this equation, and I'm going to be able to solve for my wavelength. So for me to solve for my wavelength, I'm going to divide both sides by nu. So the equation that I'll use for my wavelength, to solve for my wavelength, is going to be lambda, my wavelength, is equal to C divided by nu. Okay, so those are the two equations that I'm going to need to use. So now I should be able to plug in my numbers and solve. I'm going to use this same formatting as I've done up above. We can say, okay, my energy I know is 7.67 times 10 to the minus 19th joules. And then I am going to divide it by h. So h is going to go on the bottom, 6.626 times 10 to the minus 34th joules times seconds. That goes on the bottom. My joules are going to cancel, so I'm going to end up with per second. And then I just need to plug this calculation into my calculator. On the top here, I'm just going to put a 1. Don't actually need anything up there. Okay? So now, when I go and I plug this into my calculator, I'm going to do 7.67. I'm going to use, because it's times 10 to the minus 19th, use my EE button there, and I've got a negative 19 there. Then I'm going to divide by 6.626, use my EE button again, times 10 to the minus 34th. When I do that, I have 1.157, so I will round that. Since I have 3 digits here, I'm going to have 3 digits for my answer. I have 1.16 times 10 to the 15th, and that is per second. So I'll leave that as 1 over seconds. Okay, so now let's do our second one here. Our second equation, we're going to use lambda equals C divided by nu. So let's put C first. C is 3.00 times 10 to the 8th meters over seconds. And then because we are dividing by our frequency, we're going to put that frequency down at the bottom there. So 1.16 times 10 to the 15th. And our per seconds, our second then has to be on the opposite side of our equation. That seconds is going to cancel with our seconds, and we're going to have meters left over. So our 3 let's go grab our calculator here. 3e8, because we've got times 10 to the 8th. And then we'll divide by 1.16. Let's use our EE button then again, E15. When I do that, oh, I got this big number here. I got to move my decimal. Maybe I want to do this in scientific notation right away. So I'm just going to change my calculator over to scientific notation, and it gives it to me much nicer. So that is 2.58. Oh, I should have rounded. 2.59. Let's put our 9 there. 2.59 times 10 to the minus 7th. And that has a unit of meters. All right. So let's go ahead. If we wanted to, again, we could take that meters and convert it to nanometers. But we weren't asked about that, so we're not going to do it. Don't do any extra work than what you have to. Let's do our next question here. A photon is released with a frequency of 9.92 times 10 to the 14th hertz. What is the wavelength and energy? So again, first thing that I need to do is I need to identify the information that I have. First thing that I see here, I see a number, and I know that is my frequency. So frequency, again, is nu, and that is equal to 9.92 times 10 to the 14th hertz. Hertz, again, is per second. Okay? Then it's asking me, where am I going to go? Here's my starting point. My end point is going to be solving for wavelength and energy. So the equations that I'm going to use, again, I have E equals h nu, and C equals lambda nu. The first thing that I notice is if I'm going to solve for energy, I've already got my equation for me. I don't need to rearrange that. My second equation, though, I will need to rearrange to solve for wavelength. So to do that, again, I'm going to divide and isolate my variable. The variable that I want to solve for, I need to isolate by itself on top. So I'm going to divide both sides by nu. When I do that, it cancels out here, and I'm going to have my wavelength is equal to C divided by nu. All right, so let's do this calculation then. I get to start plugging in my numbers. First one, let's solve for E because that one was already set up for us. So my energy, I'm going to take H, which is 6.626 times 10 to the minus 34th joules seconds. I'm going to multiply that by my frequency. My frequency is 9.92 times 10 to the 14th. That's per second, so I'm going to put my seconds down at the bottom there, and I can see that my seconds are canceling with my seconds. I'm going to end up with joules at the end. That's exactly what I want. Let's do this calculation. So now, 6.626 E negative 34 times 9.92 E 14. Multiply that together, and we have 6.57 times 10 to the minus 19th joules. All right, let's do our second one right away. So our second one, again, we're going to use this equation over here to solve for our wavelength. We're going to take C, which is 3.00 times 10 to the 8th meters per second. We are then going to divide by our frequency. So we need to put our frequency down at the bottom. 9.92 times 10 to the 14th per second. So seconds goes up on top. Our seconds are going to cancel with seconds. So then when I do this calculation, let's slide this up a little bit. 3E8 divided by 9.92 E14. My answer, 3.02 times 10 to the negative 7. And what's my unit? Meters. Okay. All right. This next one, you guys should be able to try with a partner. Give it a go.